today. So, we are here to talk about terrain analysis and the ways that you and your business can use Global Mapper's terrain analysis tools to streamline your workflows. So, let's get into it. Um, so, to start, Cassidy will be joining me today. I'm Meg Scribner. I'm a host of the Geotalks podcast. Cassidy, how are you today?
Doing pretty well, Meg. Happy to be here. Happy to talk about some terrain analysis.
Awesome. Okay, great. Well, before we get into it, we're going to tell you guys a bit about our webinar format. So, attendees, you might notice that you're in listen only mode. So, we encourage you to use the questions or chat panel to communicate, ask questions, and, figure out what you need to know from the terrain analysis webinar. Um, Next, our sessions are recorded and they will be available in a follow up email. We will have it available on our video collection page as well as our YouTube channel once it's available. All right. Next up, I just wanted to share with everyone that we have a few resources available, handouts. So we encourage you to download those. There's a sample script based on one of the tips in the session. There's some resources for ways that you can stay connected with us and all of our upcoming events and opportunities, and some events and training schedules just for anybody who's curious. So definitely download those before we leave today. All right, so during this session, we are going to, well, specifically, Cassidy has prepared 10 awesome tips and tricks that are going to help demonstrate how to save time performing suitability analysis and terrain-focused LiDAR analysis. So I think without further ado, we'll move on to tip one.
All right, great. Thanks, Meg. Yeah, hey everybody, my name is Cassidy. I'm an application specialist here at Blue Marble Geographics. Talk about Global Mapper all day long, and I'm happy to be talking about it here today with all of you. You can see a quick overview of some of the tips we'll go through today. 5 in this section and then 5 in the next section for a total of 10. Feel free to throw your questions in the chat, as Meg was saying. We'll get to those as we see them along the way or clumped into groups at the end of each section. While I get into the first tip here, I'm going to go ahead and turn off my camera. Let's get into it. Tip number 1 for terrain analysis and streamlining that analysis today is about connecting to online data sources. Global Mapper has an interface to connect directly to online sources. We've got some common ones built in, or you can add your own if you've got organizational sources or any local data that's online. And it's great, you could stream it right into your workspace, but usually if you want to do any kind of further analysis on it, you probably want to save a local copy instead. Most tools work better off of files on your computer, or it's also just faster to run processing based on something you've got rather than something you're connecting to from a server far away. Often that might look like streaming some data into your workspace, exporting it, and then loading that file back in. But you can speed that up. You can see in this slide here, there's a screenshot of our Connect to Online Sources dialog with those important settings down at the bottom. These, if you don't see them, they were new in version 26.1, so it might be time to update, but if you've got 26.1 and you know you're going to want to export that data and use it locally anyway, go ahead and check those boxes to export online data directly to files, and then you can even have it set to load that exported data into the current workspace so that as soon as it's done downloading, it's already there in Global Mapper, ready for you to run an analysis on it. So that's a nice quick first tip to get us started with. The rest of them I'm going to be showing you in Global Mapper. Just didn't want to make you all wait for me to download some online data. So I'm going to go ahead and share my screen and we'll get into tip number 2.
Yes, thank you for tip number one. That was great.
Yeah, it's a nice quick improvement. Great way to just save a couple of steps there if it's something you're doing often. You can see for me to show these tips, I've got a small terrain layer loaded here. It's actually the area just around our office. Right now I'm broadcasting to you from just about here. And we've also got the nice hill across the street just for some terrain to look at. Tip number 2, it's great in Global Mapper. You can really easily see slope and slope direction with shaders. Shaders are how we're coloring our terrain grid here. Right now I have it set to show elevation, so we've just got height in meters. And if I want to see slope or slope direction instead, there is no need to run a separate tool or analysis. I can just go up to this shader menu here, the drop-down menu, and choose, say, slope shader. And now instead of looking at the elevation value for each of these cells, we're looking at the slope. There is also the slope direction shader, where instead of how sloped is it, it's which direction is that slope facing. Pretty standard here, where 0 degrees is north, 90 is east, 180 for south, and then 270 for west. We've got our color legend there. Nice and quick and easy. You can easily see what you're looking for slope-wise. If you're wondering, okay, but I like running an analysis to figure out slope, I want to know what algorithm's being used, you can control that as well. If you see at the bottom of these of the shaders, there's an option, there's a option in the menu for shader options. You can also get there from the configure menu as well. And this is where you'll find settings to control what those slope and slope direction shaders do, so they're most useful for you. For example, with this slope shader, by default, it just shows from 0 to 15. Everything above 15 is just going to be shaded black. That's just very sloped. If in your workflow you typically don't really care about anything above 5 degrees, however, you can set it here so that the maximum slope value in that legend is only 5. You can even just do that real quick here. Hit apply. And that changes the shader so that now if we only care about that, it makes it even easier to see the subtle variations in these smaller ranges we've got going on. Additionally, this is where you can choose your slope algorithm. It defaults to using the average slope with the 4 adjacent, sometimes known as the Rook's case. But if you want to do Queen's case, where it's not just the exactly adjacent cells, but also the ones that are on the corner adjacencies, you can swap to that, or you can do the maximum slope instead of the average in that area. For slope direction, we've got those built-in colors. You can change them. That can be really great for if you only care about one direction. Maybe you're really focused on finding south-facing slopes. You can set it so that west, north, and east are all the same color, maybe white, so they just blend into the background, and then south is something really distinctive. So now your slope direction shader isn't just generic slope direction, it's a south-facing slope shader, essentially, so you can get to the information you need even faster by customizing those settings. The various shaders that you're using, whether you're looking at just elevation values, slope, or slope direction, also affect some of the tools in Global Mapper, like the one we're about to talk about for tip number 3. Tip number 3 is if you want a quick vector output for areas that have that suitable elevation, slope, or slope direction, use the Vectorize raster tool. It's a little bit hidden, which is part of why I want to make sure I point it out. It's not in the terrain analysis menu because it can also be used on imagery. It works on a specific layer. So to get to it, we're going to right click on the layer in the control center, go to layer, and then Vectorize raster is right there. It's also in the layer menu up at the top of the screen too. And what this tool does is it will create area features based on the criteria we put in. You'll see there's a section here for color matching. That's for imagery. We're not going to worry about it today. That's fine. Instead, we're going to look at this elevation/slope section. And it's elevation/slope because it will extract those depending on what you have this shader set to. Since I have it set to show elevation right now, we're looking at elevation values. And you'll see I can put in a start and end elevation, discard areas smaller than I put in 100 square meters. Those areas are going to be too small to be useful. We'll take a look, and now we have those nice vector area features. Those can be great if you need to set bounds for some kind of analysis. You know, maybe you're only looking for locations that meet your criteria that are within that elevation range. Great, you can limit it to that area feature. You can crop your terrain layer to those areas if that's all you really care about. As I was saying earlier, they are based on what shader you currently have up. So if I go back to Vectorize raster now that I've swapped back over to the slope shader, we can extract a range of slopes instead. You'll see it already changed the units here to degrees. it knows we're looking at slope now. You don't need to tell it. And now we can get that nice vector output for areas that are pretty much flat, between 0 and 2 degrees. Your use obviously may vary. You might be okay with higher slope, or even 2 degrees is too much, but this is a nice way to get some vector features highlighting those areas for you. Now you could do further analysis on those vector features, see where they intersect each other, get an output that way for what has a suitable slope and also elevation or slope direction if you want. Or if you're doing a lot of work with raster data, you can use raster reclassification instead. And that brings me into tip 4, which is all about saving and loading definitions for raster reclassification. That's where we're taking our terrain grid here with our slope values, and we're creating a new one with different numbers in it, where maybe the most suitable slopes have a higher value because we like them more, and places that are unsuitable don't even get to be a part of it. If you have a couple of those reclassified rasters with suitable values in them, you can multiply them together to create a suitability index. Doesn't even have to be just terrain. You could incorporate stuff like land cover or soil types, and multiply it all together. Actually, setting up those reclassifications is kind of a pain if you do it manually though, right? I'm gonna have to put in, all right, so for slopes that are really low from 0 to 1, I like those, so I'm gonna put in a high value, and you'd have to fill in several rows. But once you've done it once, you don't have to. You can load a saved definition instead if you'd like. You'll see I've got some here. When I hit load, I set them up ahead of time, and they go ahead and fill in the values I already had. I'll hit OK so we can see what this kind of result looks like. We're going to see a higher value for slopes that are more ideal if we're looking for flat things. A kind of just a 1, it's okay if they're a little bit more sloped. And then we don't care about anything that's over 2 degrees slope, just not relevant for our purposes. In this hypothetical example, obviously you'll have your own settings. You'll see the output came up pretty quick here, and we've got that value of 2 for places with the really, really flat slope, and 1 for places where the slope is just kind of okay. Raster reclassification is something that also works off of the currently active shader in the workspace. So you'll see if I go back over to slope shader, all those values are different that we're seeing now. And if I go to raster reclassification, I can load my slope direction definition I set up ahead of time, where we're going to try and focus on those southern slopes as the absolute best or south facing, and the east-west are okay. North, no, I don't want them. I don't want to have anything north facing, too cold, too shady, not what I care about. Hit OK, and we'll see that output as well. And there we go. We didn't have to type in those definitions. We saved, loaded them. And now if we want to continue on with our suitability index as just a super basic example, just while I'm off on a little bit of a tangent here, more terrain tools that are hidden in the raster analysis menu, because again, reclass you could use on imagery, maybe something hyperspectral, but great for terrain. Same for the raster calculator. That lets you multiply any raster by any other raster, or you can subtract them. There's a lot of different math you can do. For these purposes, I'm just going to multiply them. If you have a more complicated suitability index where you want to apply weights, you can modify that formula to show them. But I'm just doing something basic. We're going to multiply them by each other so that 4, where it's 2 times 2, is the most suitable. And then places that aren't suitable in either one of them will be a 0 or no data. We don't need to worry about them. So I've set it up where my output's going to be 1 times the other. Opened up the band setup on the other monitor, but there it is. If I had weights set up, it's just asking me which is which. If I had weights set up, I'd want to be careful about which is which, but here I'm just multiplying them times each other. And then we see the output that I don't really want to be the slope direction shader. I'm just going to set it to Atlas shader real quick. And we can see our outputs here, where we've got our most suitable locations, where it was great slope and great slope direction. They'll have a value of 4. The lower ones, where it was only kind of okay, will have lower values. You can even use Vectorize raster on this, get together an area feature for everything that's anywhere between a 2 and a 4. You can prioritize it. Nice, quick analysis, starting from just saving those definitions. You can get into the interesting work of finding a suitable location later once you've, not had to type in all the values in the table each time. Moving on now into tip number 5. This one is honestly more of a collection of tips, and it's about how you can just make the most of your terrain data with some advanced settings. We're going to open my good friend, the configure menu here. It's this wrench symbol, or it might be a spanner, depending on where you are in the world. We were looking at the shader options earlier there, but we can also check out some vertical options as well. The first one I really want to highlight is this checkbox here to color elevations based on visible elevation values. Some of you listening may already know about this. It's a pretty popular setting. I know it has a lot of fans out there, but for folks who don't know, by default, this elevation shader and the legend apply to the elevation range for the entire data set. That means that when I'm zoomed in on just this little corner here, it's kind of hard to see the difference in elevation between this greenish area here and this greenish area over there, right? The only reason I really know they're different is because of the hill shade helping me out. If we check this box though, and then click apply, keep an eye on the way everything changes both in the map view and the elevation shader. Now that we're coloring elevations based on visible elevation values, you'll see that everything has been recolored. The elevation legend now only covers the range of elevations that are present on the screen right now that we're looking at. Much easier to see the difference in these areas that are right in front of me here. You'll see as I pan around, it reapplies it based on what I'm looking at, what's currently visible in the workspace. Really helpful for if you're zoomed in a really huge data set and you just want to know what's going on in one place. Related, there are some great settings in the 3D viewer that can help with similar things. It's amazing I've been talking about 3D data for this long without opening the 3D viewer, so let's get that up here. You'll see I've got some vertical exaggeration on just a little bit because this area around our office is genuinely pretty flat. But again, if I'm working with a really large data set, maybe I have vector features in here as well that are cluttering everything up, making it hard to see this one small area I want to look at. There's a setting that can help with that, and that is this one up here in the configure box, which is mask 3D data by 2D bounds. If we check that and hit apply, you'll see that I am now only looking at the section in the 3D viewer that is currently visible in this 2D map view. If you have really large data sets, you don't want to wait for it all to render, or if it's really hard to, I just want to zoom in and look at this one spot, but there's all this other stuff in the way, check this box. You don't have to see all the other stuff. You can just see the part that you're zoomed in on and really care about. Some other neat 3D viewer settings while I'm here that are a little lesser known but useful. If I turn on these elevation features that I grabbed earlier, it was for that elevation range between 50 and 70 meters so that we could, see that. It created them as 3D features with an elevation right in the middle at 60 meters. That means they're underneath a whole lot of this terrain and kind of hard to see in the 3D viewer. That's accurate, they are below it. But if we want to know where they are, there is an option where you can see them anyway. And that's this checkbox here to draw 3D vector features reflected on terrain surface. It leaves them at the elevation they're at, down there at 60 meters, cool. But also it draws them reflected onto the terrain surface, draped across it. So if you're looking to drape your 3D vector features so you can at least see where they are, rather than having them vanish into a hillside or something like that, check this box and then you can see them. The other setting I want to go over just real quick while we're here, you can also draw multiple surfaces for overlapping terrain. I've only got the one layer up right now, but if you're ever working with data where you've got a terrain layer and then something else going on underneath it that's also terrain, by default, Global Mapper will only draw on the 3D viewer the terrain layer that is last in the draw order in the control center. If you want to see all the terrain you have loaded instead, check this second option here under Configuration, 3D View, Data Display. It'll draw multiple surfaces for overlapping terrain. You can see your subsurface stuff all together with the surface itself. One last note, because I'm doing okay on time. You'll see that I'm currently using this solid background skybox. I really like it compared to the light rays in the background. It's clean, it's not so distracting. If you ever want a separate skybox though, you don't like any of these options, none of them really appeal to you, you don't want to just change the color, you can actually make a custom skybox as well. We have instructions for how to do it on the knowledge base. It can be really useful if you like this solid background, but you sometimes forget if you were looking at it from below and you forget which way up you are because it all looks the same. Or if you share a computer with a coworker and want the skybox to wish them happy birthday, you could do that as well. Less practical, but fun. That's about it for the first half here. Meg, how are we doing so far?
Doing great. I love that last tip about the skybox. So we've got a quick question from Rodney, and we're wondering, is slope only in degrees, or can you look at the percentage as well?
Yeah, let me switch back to the slope shader real quick, just so we're looking at it while we talk about it. That would be in the elevation legend here. There is this great option where it'll still shade it roughly the same, but instead of degrees, if you go to Configure, Display Options, Elevation Legend, you can check this box down here to show slope as a percent grade instead of degrees. And then we'll see that legend switch over. Nice, easy swap. Any other good questions we've had come in so far, Meg, or should I keep going and we'll catch them all at the end?
That's about it. So I think we'll catch the rest at the end. I'm
All
going to
right.
take the screen now to share our presentation again. And I actually have a tip for everyone. So, Gus Cook shared another suitability analysis workflow at our user conference this past January. So, if you're curious about that and you want to see that workflow, you can scan this QR code or head to our video collection on our website to check out some of the other terrain analysis tools that we mess with in there. So, definitely check that out. Um, Up next, we've got a few tips and tricks for terrain-focused LiDAR analysis, including some digital elevation model workflows, some scripting, and more. Users can perform terrain analysis with LiDAR data, but it's always good to have some additional insights from an expert. So Cassidy is going to be sharing 5 more of these tips, and let's find out how it works with tip number 6.
All right, great. Thanks, Meg. I'll swap it back over to my screen. Give me one moment to do that. All right, let's get into it. You'll see in Global Mapper, I've switched over to a really small little point cloud here. This is actually an area just south of our office that has some little ponds in it. The very first tip I want to say about when you're doing any kind of terrain analysis with LiDAR is to check on your classification. If you want to get at the terrain point clouds, as we can see in the 3D viewer, in general, they'll have whatever is there, not just the ground, right? You've got all these trees, we've got a power line, maybe some noise, maybe a tower of some sort. And before you make a terrain grid, you want to make sure you're only doing it from ground points. Whether you're getting a classified point cloud from someone else or you're classifying it yourself in Global Mapper or any other software, it might not sound like a step to streamline analysis to add another step in there to double check it, but doing a quick check on your classifications beforehand can save a lot of trouble down the line. As I get more into talking about these LiDAR-related features, more of them do require Global Mapper Pro, so keep that in mind, but a decent chunk of them are still doable even in standard in some fashion. For example, here, just take a quick look. This point cloud is already classified. It's a nice little USGS point cloud from our government here in the US. They're great, publicly available. My favorite way to just check on the classification really quickly is actually to filter out everything but ground points. So I can open this Filter Lidar Data button and then right-click in the list here to uncheck absolutely everything, and I'll put a checkbox just next to ground and hit Apply. You'll see that now we've lost those water points. There's a bit thinner looking in some spots. There's some gaps where maybe there was dense vegetation. But now that we've filtered it, if we take a look in the 3D viewer, it's essentially a preview of what that DTM we create is going to be. Obviously the point clouds aren't going to interpolate across these gaps for us, but it's a great quick way to check that you don't have any suspiciously roof-looking things or shrubberies that got caught up in the ground classification before you turn them into a terrain layer. Since it all looks good, let's go ahead and make that into a terrain layer real quick using our Generate Elevation Grid button up here. Because I currently have a workspace filter set up for this point cloud, it'll only make that grid based off of those ground points that are currently visible. If all of the points were still visible and I hadn't filtered them in the workspace, I could use this button here to filter them. Not necessary right now though. We'll just go ahead and hit OK. I'm going to use the binning method here. I like it for making DTMs. It just grabs the lowest point in the bin size you specify and makes that the grid. But oh no, what happened here? If we take a look back at the point cloud, you can see that on the edges of these ponds, the points are a little bit iffy. There are some gaps, there's some really different elevations here. Even though it's a pond, we know the water will be flat in it. But Global Mapper was trying really hard to interpolate across that based on the data it had. Fortunately, tip number 7 is that you can hydro-flatten those water features, so you don't need to worry about bumpy, odd DTMs. Here, we're fortunate there aren't any points here once we've filtered just ground, but LiDAR tends to be a little bit funky with water. Traditional scanners, water's really reflective, it's moving, it's odd shapes. If you're doing a photogrammetry-based point cloud, photogrammetry has trouble capturing water and reconstructing it for the same reasons. Fortunately, we can ignore all that here. I went ahead and earlier on, I drew some quick vector area features for the location of these ponds. I just digitized based on the boundaries of the point cloud, but you can get these area features in a number of ways. If you've got your own area features for bodies of water already, or you could do something where maybe you're making a coverage polygon for the point cloud. It'll be an area feature with an island where there's a big gap and you could turn that island into a vector feature. However works for you. Once we've got these 3D vector features, then if I go and, create my elevation grid again, make sure those vector layers are on, you'll see that this option down here is now available. And it'll let me use that 3D area or line feature as a break line. And what that does is it tells Global Mapper, hey, don't interpolate across there. We've got a 3D vector feature, just use that elevation instead. And so now when I hit OK, you'll see this grid looks a whole lot nicer. We've got those lovely flat ponds rather than a funky, lumpy surface. There is also a way, if you've got Global Mapper Pro and you already made this grid and you just don't want to go back and make it again, that is also a nice extra method of hydro-flattening with our terrain painting tool. Let me turn one of these ponds back on. Open up terrain painting with that kind of paintbrush over terrain icon. There are a lot of options in terrain painting for modifying your terrain grids, all depending on what you need to do. In this case, we're looking to set the terrain height. And rather than drawing a new feature, I've already got this vector feature here, we'll choose the Paint Selected Features option. I'll select this feature, set a height, that pond is at 133 meters, and we'll hit Paint Selected Features. Nice, quick, after creating the terrain grid hydro-flattening, fixing that issue with the DTM where it was trying to deal with some incomplete points around the edge of that gap. All right, moving on into our next tip. This next tip is that you can script tedious workflows, such as converting a lot of different point clouds into terrain models. For this one, I did actually pre-record the tip because a huge advantage of scripting is that you can process many, many, many files at once without having to sit there clicking buttons, and I wanted to show that, but also not make you sit through several minutes of just dialog boxes and progress bars. So we've got that pre-recorded so we can cut past the actual script running part once it gets started. And Meg, if you could go ahead and get over into that video now.
This one will be to use scripting to automate tedious processes. Imagine a scenario where you have just a whole lot of LiDAR or other point cloud data that you need to convert into terrain grids. It's already been classified and you really trust that classification. You just have to get through it all and convert it the way you need to. Normally that might look something like, load each file, convert it to a terrain grid, and then export that grid to whatever file format you need. That works great when you're doing it for just a couple files, but if you have a lot of them, it'll still work great, but it'll take a while, especially if any of them are larger files where they might take a little while to process or even just to load if they're really huge data sets. And that's not fun. That's kind of boring to sit there all day clicking the same buttons in a row. So let's automate it instead and have Global Mapper take care of it in the background for you. Scripting can be intimidating for folks who've never really done it before. But Global Mapper fortunately has some tools to help make it a bit more accessible and get you past the learning a whole new skill set and faster into the just doing it more easily and saving yourself some time and effort. My personal favorite of those tools is the Script Builder. You can see it up here on this toolbar. If you don't see this toolbar, it was new in version 26.1. Previously, the Script Builder and Script Editor were only in the File menu, but because they're so useful for this kind of automation, we gave them their own toolbar in 26.1. The Script Builder, you'll see it's empty right now, but what that will do is you'll see it has a little recording button. As I follow steps in my workflow in this workspace, it will generate the equivalent scripting commands. So if I go ahead and create an elevation grid, we're going to filter to just only use ground points. Keep all the other settings the same. Those are fine. Let's use binning, minimum, cool, and then hit OK. It created the terrain grid, but also we now have the equivalent command in Global Mapper scripting. It's basically just how would you tell Global Mapper in a script how to do the exact process I just did rather than clicking on those buttons. We can take those commands, copy them, and then open the script editor to take a look at them there. You can also write Global Mapper script in any text editor. You can write scripts in Notepad and then just change the file extension to .gms for Global Mapper script. But if you have access to Global Mapper Pro, you also have this script builder and the script editor that helps to color some of these texts, make it a little bit clearer what we're looking at. The other really important scripting resource we have is in the Global Mapper knowledge base. There is a scripting reference that has detailed information on what each of these parameters mean for each of these commands, along with how to write out commands for stuff that you can't do in the interface, like loop through an entire folder of LAS files. To save a little bit of time here, not get too bogged down in all the immediate technicalities, I did already make a whole script for this workflow. It will be available to all of you. I'm not sure right now. I think we're either sending it out right after the webinar or Meg might be putting it in the chat right now. So keep an eye out for that. But let's take a look at it. I already have it in this nice little favorite script manager dropdown that was also new in version 26.1. So let's open our grid lidar.gms in the script editor. You can see down here I've got that generate elev grid command I took from the script builder. And then I also, earlier on, off screen, went ahead and got a command in that script builder to export to a geotiff as well. I also went ahead and set up a loop so it'll go through all the folders in a directory and then do this to them, create the grid, and then export it to a geotiff. And at the top, I set up some basic prompts to ask, hey, where is that folder full of last data that I want to look at, and where do you want those geotiffs to go? That could have been static. I could have just written in a file location, but I figure having the script run to a specific location on my computer is just not very useful for you, so it's probably best for the script to prompt instead. And again, most of this is from the script builder or some pretty straightforward stuff from the scripting reference. Let's go ahead and close that out and just go ahead and run it from this favorite script manager. We'll hit the button to run. It's asking me for my input directory that I set up over here with just a whole bunch of different point clouds in it. It's asking now, you can see the prompt here for an output directory. Let's put them in this output folder I set up. And it will start running. The other major advantage of scripting that you can see here is right now I don't have it set to run in the workspace. You won't actually see these various point clouds show up in Global Mapper. It's just processing them in the background. That can also really save time. If you don't really need to actually visually look at your point cloud, scripting lets you skip over that step where the computer has to actually draw out and render the whole thing. It can just get on with the processing without having to show you what it's doing the whole time. That also saves some time and resources. It looks like this is going to take a little while, which makes sense. That's why I've set up the script to do it. So I'm actually going to turn off my mic for a moment while this records and grab another cup of coffee. I'll be back in a minute. All right, I'm back and it looks like my script finished running. So let's just take a quick look at those outputs. It's the inputs folder. We'll navigate to where I saved the outputs and see, hey, look, there's a whole bunch of TIFFs in here. Let's go ahead and open one up. And you'll see we now have a lovely terrain grid from those ground points. And all of them processed without having to repeatedly open this dialog and pick your settings and then manually export it. The script took care of it all for you. That's a great way to streamline anything that you need to do frequently, which is pretty tedious. You know, if you're only doing something once, writing up a whole script for it might not be worth the time. But if it's something you do often, write up a script that takes care of the steps for you, throw it up here in your favorites, and then you can run that whenever you'd like and save yourself some time and energy. Thanks.
All right, great. Thank you so much for playing that video, Meg. I'll get back over to my screen now for the next
Awesome.
tip. But just want to give another shout out to scripting as an option. You know, even if you never are looking to script converting a bunch of LiDAR files into a DEM, hopefully that script sample can be helpful for you. It's a great example of just how to set up a loop through a directory. You can absolutely copy paste the prompts in there that ask you for where your input and output are. You can use those for any other script you set up, maybe creating a suitability index like in that earlier tip. You can script that entire workflow of reclassifying rasters and then multiplying them together if you really want to. It's an incredible tool. But anyway, moving on, got to get to tip number 9 first before we all, go and learn about scripting. Tip number 9 is you can identify model key points to really intelligently thin your point cloud down and keep only the points that are most important to show the shape of that terrain. If we take a look at this point cloud still filtered to just ground in the 3D viewer, you'll see that there are a lot of points here. Okay, it's not that dense of a point cloud. It's not as many as in some more modern ones, but even in these flat areas, there are a lot of points. We don't really need those to know what shape the ground is when we look at it. Fortunately, Global Mapper has a really nice tool to separate out just those points that are most necessary. It's really useful if you're looking to export those points to another program that maybe doesn't like having 100,000 ground points in there at once. To get there, we'll actually go up to this classification menu in the LiDAR toolbar and open the automatic point cloud analysis tool. If your point cloud was unclassified, you needed to classify ground, this is also where you could do that. There's a whole section for it. We have a lot of explanation about the settings on the knowledge base. Little beyond the scope of this right now though, so I'll go ahead and just minimize that section. And we'll take a look at the flags to apply. This is where we can, rather than classifying points as model key points, unless you want to, you could, we'll instead apply a flag, marking them out as these are key to the structure of the overall terrain. I'll go ahead and set it to run while I talk about these settings a little bit. The way it works is it creates a tin, so a triangulated irregular network, out of the points. And then if faces of that tin, if those triangles are really similar to each other in orientation, it will combine them. So there are fewer and fewer vertices, and those vertices are the points in the point cloud. I have it set to save that tin to a new layer. So let's just take a look at what that output looks like. You'll see that it is so many fewer points, right? In this first one, we had about 250,000 if you count all of them. How many ground was that? About 100,000 ground points. We're down to 11K. Way easier to work with, much faster. And you can see here, we've still got the shape pretty well preserved. If we take a look in the 3D viewer, we've still got this raised area here. We've still got the edges of those ponds, even where the points are a little bit funky and missing at the edge. And we still have the shape of that road that cuts through the area as well. So if you need a smaller point cloud, flagging key points is a great way to get there. It can also output this mesh of the tin. It's great if you just want to see what it was doing. You'll see that the points match up with the vertices there as well. Moving on now into our final tip, tip number 10. This one's another collection of a couple different things, and that's really making the most of the path profile tool with some advanced settings there. You saw earlier, I used it to show why the pond might not come in all that well because there was just a huge difference in height on either side of it. But there's a lot more it can do. It's extra useful for looking at LiDAR, but even just for regular terrain, incredibly useful analysis tool. To get to the settings for the path profile, first I drew a path profile by left click and right click. And we'll go to this button here where it's got that wrench for settings on top of the path profile icon. There are a lot of settings in here. So many so that a version or two ago, we actually had to break them into multiple tabs because the screen was getting kind of unwieldy. Which ones work best for you really vary. The ones I want to highlight are all in this data display tab here. You'll see that by just turning layers on, we can throw on our DTM, we can throw on a couple different layers, and they're already in here. But I turned on those ponds and they're not. I can make them show up though. And that's this section over here where you can choose to draw other vector data in addition to your terrain and point cloud. Specifically, this draw line/area features. When I hit apply, that's where my pond is that crosses the path. So you can really see the effect that hydro-flattening had, where that started and stopped, plus that sort of feathered area on the side. You can also draw 3D point features in the path profile. That's really great for if you have, say, ground control points and you want to see them together with your terrain and your point cloud. Draw your path profile across them, check that box to draw 3D points, and they'll be right there for you. Another setting here that I really like is this one up here to draw a separate line for path from each terrain layer. By default, again, the path profile will only show the most recently drawn terrain layer that is present. So if you have multiple on, you'll see it just changes what's going on there. Let me actually draw a path over the pond I didn't flatten instead. Be a bit more striking of a difference there. If you want to see both of them at once, you can go ahead and check this draw separate line for path from each terrain layer option, hit apply. We now have multiple lines in our path profile. I always check this other box as well to have a legend. That way I know which line is which. Incredibly useful for if you're doing any kind of a comparison analysis, maybe a before and after or multiple possible scenarios. So you can show them next to each other along with any other vector features you have, plus any point clouds that get involved as well. The final path profile settings I really want to highlight here are also kind of display based. Talking about these lines here where we're drawing multiple lines, if you want to see different ones, you can absolutely do that. It's a little bit hidden, but if you right click in the path profile at any point, there are a bunch of other display options. You can customize this, set background color, cursor, text, font, and also the style and color for those terrain layer lines when we're drawing multiple of them. You can control the point cloud Lidar draw mode from here separately from the workspace if we want to see the classification. Maybe we're turning the whole point cloud back on. We want to see all of those points in there. Plus, this other dropdown is for the terrain shader as well. You're probably familiar with seeing the path profile. It's always green. You can make it show any of the other shaders as well if you really want to highlight those elevation differences as well. Finally, there's this little box down here about 3D display, and that's how path profiles are shown in the 3D viewer. By default, it's set to render path profile only, and that way, when I open the 3D viewer, it would just show a line for where the path profile is. Not very interesting. Instead, if I want to see it better, or perhaps slice up my data, you can render a single terrain cutaway. I'll hit apply. And then before I open the 3D viewer, I want to check one other step. Since the 3D viewer has its own settings, I'm just going to go back to there real quick. Make sure the box is checked to even show the path profile visualization. Don't want the 3D viewer's own settings overriding it, but let's take a look at what this looks like. Now, instead of just drawing a line on the ground, my path profile created a cutaway, so I can see I've got my point cloud, I've got my terrain grid, I've got my vector features, and that path profile sliced away for a nice cross section as well. Hopefully some of those options will be helpful for y'all. I know we've got folks on this webinar today from a wide range of backgrounds and fields and experience levels, but my hope is that at least one of these tips is something that'll help you out going forward with Global Mapper. Meg, I'll turn it back over to you so we can start getting into some questions.
Yes, absolutely. But first, I just wanted to share with everyone that if you aren't a Global Mapper user yet and you were interested in any of the features that we talked about today, I definitely recommend downloading a trial of the software. We have 14-day free trials, and we even have some that are segmented. We have trial download pages that are segmented by industry. So we've got all of the resources that we have for that industry on these landing pages. So type it right into your browser and look it up and you'll be there. So definitely give those a try. But let's jump into the Q&A. Alrighty, so Cassidy, one of the first questions that we have is, can Global Mapper automatically rectify scanned maps using AI, like detecting and matching features or control points without doing it manually?
Figured I'd turn my camera back on now that I'm just answering questions. If I have anything to show, I'll switch back over to Global Mapper. Global Mapper does have some AI capabilities, and we've been adding more and more recently. Those are mostly in the Insight and Learning engine, which is currently in beta. If you have Global Mapper Pro, please check it out, give it a try. So far, those are features for image analysis. We have tools to automatically do land cover classification from images, aerial imagery, as well as to extract buildings from aerial imagery and detect vehicles. Those are all pretty new. They're customizable. If you want to detect or extract some other kind of vector features from them, there is fine tuning available where you can modify the built-in models to better suit your needs. Or you can even do a full training and create your own model if you have that large quantity of training data and you just need an interface to be able to plug it into. Right now, addressing this question more specifically in terms of automatically rectifying scanned maps, we don't have that capability right now, but it sounds like it would be awesome. I'll definitely pass that on to our product managers. I know they've been looking into more kinds of features to add, and that would be really nice if you could get some historical maps and have an easier time matching them up without having to put in all your control points all on your own. Yeah. What other kind of questions do we have, especially anything terrain related? I know we had one earlier about showing that setting again for seeing the terrain shading just on what's currently visible locally. I'll go ahead and share my screen just to pull that back up. If anybody else has some interesting questions, throw them in the chat. Sharing my screen now. Turning off my camera to make it a reasonable size. And that would again be, if I'm zoomed in over here and I want to just have the elevation for right here, we'll go to this configure menu, go to vertical options, color elevations based on visible elevation values. Check that and hit apply. It does what it says. It'll color them based on what's visible rather than what's loaded. Just really great setting for all of that. Taking a look in the chat now as well. Oh gosh, we've got a bunch coming in. Again, as I believe Meg was saying, if we can't get to these questions just now, we will follow up with you afterward.
Yes, absolutely. We will be following up with everyone afterward. But yeah, we've got a lot coming in. The next question that I had set up for you, Cassidy, was from Gilbert, and Gilbert was wondering, is there a way to create area features or a hole around a point cloud, like what you used for the
Mhm.
ponds?
Yeah, so for these ponds in particular, because it's relatively lower resolution point cloud, I honestly just digitized around them. I've only got a couple to set up. I just opened the digitizer and drew my line feature. I'm not going to go back through it now. Um, One way, especially if you have a higher resolution point cloud and you are looking to automate this in some way, one thing I've experimented with is if you make a coverage polygon around it. So I'm going to right click on the layer over here, go to layer, bbox/coverages. Yep, for my point cloud. And then create a polygonal coverage area that's really, really rough. So it's not smooth at all. We're going to be really tightly around these shapes. Then what I can do is if I select this area feature, right now it's an island. This whole rectangular area covering the whole point cloud is the actual area feature, and it's just got a hole in the middle of it. But the digitizer does have an option. Okay, it might take me a moment to find it because the digitizer can do so many things. Where you can take an island and make it into a separate area feature. Create new area feature from selected island. I'll create, I'll call it pond 3 because I've already got a pond 1 and a pond 2. So now I'll turn off the coverage polygon, and instead I have an area feature that's pretty close to the boundaries of where that pond is, and I can use it for that hydro-flattening workflow, right? We'll make sure our pond 3 is selected, click OK, and we've got, I hadn't set an elevation for it. It is currently down at, I believe, possibly 0 because it doesn't have an elevation attribute. You would need to assign one as well there. The way I determined the elevation for these ponds in this one was because there were points for them as water, I used the feature info tool to just check on what elevation all that water was, and you can assign that elevation to your vector feature as well. But stealing islands out of coverage polygons can be a quick way to do that if you don't want to sit there digitizing, especially if you have a lot of different water features that you need to make these vector areas for.
Yeah, absolutely. So we actually have a follow-up to, not necessarily a follow-up, but a related question to one of the questions that we got earlier. So when vectorizing a raster, is there a way to specify slope values in percent slope instead of degrees? And they specified not in the legend display like you showed live, but in the input values before running the tool.
That's actually a very good question. Let's take a look. Now that it's set to percentages, I think it might need to be in degrees. Let's find out what happens. It still says degrees. I suspect it might need to be degrees. I'm pretty sure we have an existing improvement ticket about adding the ability for this to be in percentages as well. I'll double check with that, and if we don't, I'll create one and pass it on to our product management. That would be a fantastic capability. Yeah, it looks like it still went off of degrees rather than the percentages I've got right now. So I will check on that and add that, yeah, there's interest in it. It sounds like something that should be relatively straightforward. Vectorize raster is already obviously looking at what is going on in the map view when it's determining what units to put here. So hopefully there's a way it could tell in percentages as well, or just let us choose it from the drop down like it will for feet or meters. Good, great question.
Yeah, thank you for answering that one, Cassidy. We have one more question that we're going to do live, and then the rest we're going to get to after the fact. But we have someone wondering where the filter was to turn off or eliminate vegetation because they couldn't find it in their program.
Oh yeah, absolutely. So I am working with a point cloud that is already classified. If your point cloud isn't classified, the whole thing will probably be all these just gray color. That's the default color for unclassified. Um, if it's classified though, there's this filter LiDAR button. It's in the LiDAR toolbar, or you can get to it from the LiDAR analysis menu. We'll open the interface to filter LiDAR data. And that pulls up the list of classes where I can uncheck everything but ground. Uh, hit apply, and it cuts out all of those gray and blue and red points that were unclassified, water, or noise. If you're still having trouble finding it, please don't hesitate to reach out to us. Our support team is pretty good at tracking down missing buttons. Um, always happy to help out with that.
All right, well, I'm taken back over as we transition to the end of our webinar. So before we end the webinar, we have a survey that is going to be available immediately following the webinar. And it's also going to be available in the follow-up email. If you enjoyed this webinar, if you want to attend more, but you want to have kind of a say in what we're doing, definitely fill this out. It'll be a great opportunity for us to know what you're interested in, and we would love to hear from you. So that's that. Definitely take that afterwards. And thank you for joining us. Let us know if you have any questions. And thank you so much for attending. Great to see everyone, and we'll see you soon. Bye.
Bye, everybody.